1 by omega C 60 ohms and an inductor coil. The circuit is found to resonate. So in resonance, XL is XC. So that is omega L is 1 by omega C, which is omega is 2 pi n into L. What we have to find out is inductance of the coil. So here it is 60. By 2 pi n. Pi he given here roughly 3. N is frequency 100 Hz. So 1 by 10, 0.1 hundred. So dimension of mass in new system. So energy dimension formula, momentum mass into velocity, force mass into acceleration. Mass we have to express in terms of, so given these as fundamental quantities, energy, momentum and force. ml square t power minus 2a ml t power minus 2 of c. Comparing like powers, here it is a plus b plus c, which is 1. So 2a plus b plus c is 0 because length is not there. Time power minus 2a minus b minus 2c. Left hand side, this is nothing but L power 0, M power 1, T power 0. So say this is 1, 2, third equation. Adding second and third, my plus 2a minus 2a plus b minus b get cancelled. C0. C0 means a plus b is 1, 2a plus b is 0. So subtracting, we get the minus a as 1. So once a as minus 1, substitute in first equation, we get 2. See, already we know it. So finally, so mass, we can write e power a, that is minus 1, p power b, which is 2, c power 0. This is dimensional formula for mass. And here it's aimed at an angle above the horizontal with a velocity v0 towards a vertical cliff at a distance r. Once it is projected with certain angle, alpha, the vertical displacement and horizontal displacement are related by a formula. Y is x tan alpha minus half gx square by u square cos square r. Here in this problem, he given you as v0 is asking at a distance of r, height of the cliff he is asking. That is height, here y is height of the cliff X is here r tan alpha minus X here is r square. Straightforward question. Here AB and BC each of length L by 2 made of same material. Same material. Specific resistance is same. But for first wire AB 2R, sorry, this is radius is 2R, and for second one radius is R. So R is equal to, R here stands for resistance, rho is specific resistance, length here is L is the length, which is half of it, L by 2, area pi R square, because for a wire, cross-sectional area is a circle, 2 pi R in the sense here, 2R whole square. For second wire, that is BC, same material, same length, but radius is R square. From here, R1 by R2 means rho L by 8 pi R square by rho L by 2 pi R square. So, which implies R1 by R2 here is 1 by 4. So, which implies four R1 is R2. So potential difference across AB is, since both are in series, current will be same, only depends upon resistance. It is IR1, IR2 is 4 times R1. So potential difference is 4 times potential difference across BC is 4 times potential difference across AB. So first option is power here is V square by 4R1. So for a power V square by R1, because both are connected to a battery whose potential difference is V, only power changes. So here P2 will be, R2 is 4R1. So power in BC, power dissipated in BC is 1/4 of power dissipated in AB. So better correct it 4 times. First option becomes correct. 4 times. Second one, this 35th one, acceleration is, so since acceleration varies, velocity will be calculated with the help of integration. Integral V is equal to, starting from rest, at t0, velocity 0, starting from rest means, so 0 is equal to, so which implies velocity is, so third option is correct, or third option of kt square plus 50. Second option is correct. So a block is released from a rest from the top of inclined plane, smooth inclined plane whose angle of inclination is theta. So when it reaches bottom, speed is v. The same block is released from the rough inclined plane of same inclination as a speed v by n on reach, where n is number greater than unity, then okay. So same block in the sense here. Only thing is, instead of rough surface, smooth surface, here rough surface. That is same angle of inclination. Starting from rest here, when it reaches bottom, so in case 1, u0, let us say L is inclination, so L is length. So here it is 90 minus theta, g cos 90 minus theta. So only force is gravitational force component, that MA is mg sin theta, A will be this. So V square is, so inclination length is this. In the second case, body is moving like this, frictional force acts on this. So it is N is mg cos theta. So net force will be, that is V here is, so now V dash will be, it also started from rest, acceleration is, and that's V dash she given it as V by N. When it reaches bottom, now we have two relations. One is this, So dividing one with other, v square by n square 2gl n square is here it is. Answer is given in terms of tan. Divide with cos, both numerator sin by cos 1 minus tan theta minus mu. Tan square theta minus n square mu is tan theta. So he's asking mu. So mu n square is tan theta into n square minus 1. So mu will be 1 minus 1 by n square tan theta. So first option. The 37th one, two blocks A and B are connected to each other by a string and a spring force constant. The string passes for a frictionless pulley. Block B slides over the horizontal top surface of a stationary block. So block A slides along the vertical side of C. Okay. The mass of the block is A is M. What is the mass of the block? Here spring force, here it is. So restoring force is developed. Okay, so at this point, that tension is restoring force. Here also same tension, T is equal to what mass of the block B into acceleration. But he says string passes over a frictionless pulley. The coefficient of friction between surface of the blocks. Here there is a friction. So mu n here is mg. At T becomes mu n that is mu mg with uniform speed. Uniform speed means acceleration zero. Otherwise, we have t minus mu mg is ma. Right, this acceleration zero here. This is mass of the block B. The T is kx, which is same as mg, which is mu mb of g. Mass of the block B is electromagnetic radiation point source. Operates at 250 watts with a 10% efficiency. Original power is 250 watt. Efficiency 10% means that is 25 watt. Average energy density is half epsilon naught so intensity is equal to the point source intensity is inversely proportional to R. As R increases, intensity is power per unit area. So intensity decreases. That is one formula. Another, intensity in terms of energy, electric, in terms of energy, I will write. So here energy density is energy per unit volume. So here it is E is equal to VUD. So power here is E by T, that is V is area T. Area here volume, area into length into energy density. Intensity is power per unit area. That is L by T is nothing but velocity of light. It cancel. So UD is this into C. So these two are equal. You have to calculate energy density. Means this we have to calculate UD into C. That is 25 by 4 pi. R square is 100 by C, velocity of light. 25 by 12 pi into 10 power minus 10. So here it is 36.6 times roughly joule per meter cube. Here, a body of mass 1 kg is dropped from a height h 40 centimeters on a horizontal platform fixed at one end. The other end is fixed to a base. Okay. As a result, the spring is compressed. So the next situation, when body hits this platform, spring compresses by x meters, then potential energy that is converted to energy when it is fall through a height h plus x, that energy is converted to energy in the spring, which is half kx square. He is asking find force constant. Mass is given 1 kg, height is centimeters is given, x centimeters I will assume, half k, that x also he given, which is half k into 1 by 100. So 102 times k will be 2g into x is 10 into 50,000 Newton per meter. A body P strikes another body of mass that is P times that of body. Let us assume mass of P as M, mass of Q will be P times M, and moving with a velocity 1 by Q that of V. So velocity of this body P, if I assume, velocity is this. And after collision, body P comes to final velocity of P0, the coefficient of restitution. This is what the question. Coefficient of restitution, velocity of separation by velocity of approach. So final velocity of second body, I don't know. V1 is 0. Final velocity of first body, here it is V minus V by Q. To find out final velocity of first body, momentum is conserved. So momentum of the first body plus momentum of the second body, momentum of first body after this collision, momentum of second body after. So M into Q plus P by Q of V, Pm into V dash. V dash will be Q plus P into V by QP. So restitution, this is V dash is nothing but velocity of second body after collision. So this is P plus Q by P into Q minus 1. Here 41st one, moment of inertia of a square plate about through a line perpendicular to the plane and passing through the center of mass is ml square by 6. So let us take these two are Ix and Iy, it is Iz. By perpendicular axis theorem, Iz is equal to Ix plus Iy. So here it is. This figure is symmetric with both the diagonals. Ix definitely will be Iy. Iz is so ml square by 12. 6 is equal to 2 times your x in the sense diagonal AC. So ml square by 12. Here, uniform rod of mass capital M is hinged at a frictionless pivot at O. So at end. So diagram it is shown like this. It is the end is O. A bullet of mass M is moving horizontally, strikes the free end of the rod and gets embedded it. Here it is totally one system. Momentum before collision mv is equal to this is angular momentum is conserved because bullet plus rod is one system. So bullet is moving and it is hitting. No other force is acting on the rod. So torque is 0. Angular momentum is conserved. So about this point, if I find angular momentum formula MVR, here R means about which point you are calculating, that is this point you are calculating. So MVL, which is I omega. So that is here about for a rod through center of mass perpendicular is ml square by 12. About end is ml square by 3. So moment of inertia about O. The moment of inertia of rod about O is ml square by 3. Now, but total moment of inertia after embedding this bullet mass will be here. So moment of inertia of rod plus moment of inertia of bullet. ml square by 3 plus. So this mass is at a distance L from this point, ml square. Here capital M, small m stands for bullet mass. L square m plus 3m by. So here what we have to calculate is angular velocity after collision. So MVL I here is so L square m plus 3m by 3 omega. L get cancelled. Omega is 3 mv by L into m plus 3. The two masses of radii of Earth and Moon. This one is, here you have a moon. Distance between them, their centers are distance d apart. The minimum speed with which particle of mass is projected from the midpoint, small mass m, projected between the two centers to escape from the to infinity. Escape to infinity means total energy here is zero. The total energy is, first when it is here, it is projected with some velocity, that is particle mass is projected, and with respect to Earth, when it is on the surface, potential energy is this, but at this point potential energy is due to Earth R1 he given, radius of the Earth, due to Moon, here M1, Moon mass is this, R2 plus, here also it is R2, total distance. So for escape, this energy must be zero. So this is better to write. Since he told midpoint, I'll write d by t. G m to m 2 by d, g m if you take common, half mv square. So v square will be 4 by d g m1 plus, which will be v by 2 times g m1 plus w. So second option is correct. A satellite is launched into a circular orbit. The period of the second satellite. So relation between period and radius. The change is very small. I can take help of differentiation to find out change in period. Log t square is 2 log t is log k plus 3 log r. Differentiating 3 times. So originally radius launched into a radius of this. There is a change in the radius, that is 0.01. Or get cancer, which is 3. So, percentage change in this, that is 1.5%. So there are 26 tuning forks arranged in decreasing order. Each tuning fork is 3 beats with the next. Let the frequency of first tuning fork be nu, or let me write f. So each tuning fork gives 3 beats with the next. Let us say f, f minus 3, f minus 6, or f plus 3, like this. 26 tuning forks are there. It is f minus 3 into 1. So next, if you write f minus 8, 2 times 3, 3 times 3. So on 26th one will be, fourth one is 3 times, third one is 2 times, 26th one will be this. The first one is octave with the last one. So here, meaning of an octave. So what is octave means? An octave is the interval between one musical pitch and another with double or half of its frequency. So that means if one note frequency, for example, 400, it can be 800 or 200. So here, since they are decreasing, so first one is octave with the last means 2 times f minus 75. So this is 2f minus 150. So f here is 150. Frequency of 18th. Frequency of 18th tuning for f minus fourth one means 3 times 18 is 150 minus 51, 99 H. Rajan?